Lesson 2.3 is on rate of change and slope. So the first thing we're going to do is look at rate of change. And so the rate of change is the ratio that compares how much one quantity changes on average relative to the change in another quantity. And so notice down below I have formulas for the rate of change. I'll go ahead and let you get the definition down, and then we'll talk a little bit about the formula. So now the rate of change is defined as being the change in y over the change in x. So how much something changes on the y-axis, and then divided by how much something changes on the x-axis. Now if you notice, there's another formula down below, and some of you are probably wondering, oh my gosh, what in the heck is that? Okay, this is actually the Greek symbol delta. And what the Greek symbol delta stands for is that stands for change in. So this formula on the very bottom is identical to the formula in the middle of the page. So when you see delta, that means the words change in. So delta y means change in y. Delta x means change in x. So it's just a shortened or an abbreviated way of writing the rate of change formula instead of spelling it out with words. So now what we're going to do is we're going to look at some formulas dealing with some examples dealing with rates of change. And so if you look at this, this is actually taken from your book. It says the table shows the temperature of a solution after it has been removed from a heat source. Find the rate of change in temperature for the solution. So we need to do the change in y divided by the change in x. So the rate of change is the change in y. So the change in y is going to be this temperature column right here. And so what I'm going to do is I'm going to pick the latest value, which in this case is 118.4. So I'm going to take 118.4. And I'm going to subtract from that the initial value, which is 143.6. So that's my change in y. Can somebody tell me what they think I'm going to divide by? Okay, close. It's actually going to be the other way around. It's going to be 12 minus 0. So the first terms in your fraction need to correlate. So the 118.4 and the 12, they correlate. They're on the same row right here. Okay, likewise, the 143.6 and the 0 correlate. So now all I need to do is calculate that. So let's go ahead and take 118.4 minus 143.6. And what do I get? 118.4 minus 143.6. Negative what? Negative 25.2. Somebody else get negative 25.2? And I'm going to divide that by what number? 12. Now, when I take negative 25.2 and I divide that by 12, what do I get for my rate of change? Negative 2.1. Okay, now I need to come up with a formula. So it changes negative 2.1 degrees Celsius per minute. Now, if you're wondering where does that come from, I started with temperature. That is my degrees Celsius, so that's going to be the very first label. Okay, what I did then is divided by the time, which is minutes. So that is the rate of change. Now, why is it negative? Because it drops, it goes down. So you can have a negative rate of change. That just means that something's decreasing. If it's positive, what do you know? It's increasing. Okay, so let's go ahead and look at another example. It says the graph at the right shows the number of gallons of water in a swimming pool as it is being filled. Hopefully we'll have our new swimming pool this coming summer. At what rate is the pool being filled? So if you notice in this diagram, we already have 2 points selected. So I'm going to find the rate of change between these 2 points. So the rate of change equals. So I'm going to look at those 2 points, and I'm going to just start with the 252. So I'm going to take 252 minus what? 108, good. So 252 minus 108 divided by 7 minus 3. So 252 minus 108, what is that? 144 divided by what number? 4. So if I take 144 and divide by 4, I get a total of? 36 even. Okay, so now it says at what rate is the pool being filled? So 36 gallons per minute. So when you think about that, 36 gallons per minute, that's like a gallon every 2 seconds. That's a lot of water. Okay. So that's like a gallon, a jug of milk every, it's actually a little less than 2 seconds. So, pretty fast. Let's go to this next one. It says find the average rate of change for the percent of total music sales for both CDs and downloads from 2001 to 2008. Compare the rates. So now if you notice, I've got graphs of 2 things. I've got CDs and I've got downloads. So obviously you can see this is something that is actually happening now, except for I would see that the CDs, the trend is probably continuing going down. And what's happening to downloads? It's going up. That's with the advent of iTunes and the other download software. I'm sure it's similar with DVDs as well. So let's go ahead and start with CDs. Okay, we'll do that in blue. CDs, we're going to do the average rate of change. So, R of C. So what I'm going to do when I want to find the average rate of change is I'm going to use the 2 endpoints here. So the 2 endpoints are 89.2% and 77.8%. Okay. So in this case, I'm going to take 77.8 minus 89.2. And what am I going to divide by? Yep. 2008 minus 2001. Okay, so 2008 minus 2001. So what is 77.8 minus 89.2? Negative 11.4 divided by 7. What does that come out to be? Negative 1.63. So it goes down negative 1.63% per year. Good. Okay, so let's find the rate of change with the downloads. Rate of change with the downloads. What am I going to take? Yep, 12.8 minus 0.2, and then I'm going to divide by 2008 minus 2001. Okay, so 12.8 minus 0.2 is 12.6 divided by 7. And so that comes out to be what? 1.8% per year. So if you notice, okay, it averages an increase of 1.8% per year on the downloads, and with respect to the CDs, they average a loss of about 1.6% per year. Questions? All right, now this is going to look pretty familiar. Okay, this is the same thing. Do you think we need to look at this in words? Or do you think you can handle it? How about we set it up? How about we set it up, we don't have to work through it. Okay, so first of all, if you notice what this says. This says in 2002, 23,142 students applied to a college and 34,689 students applied to a university. In 2010, 29,563 students applied to the same college and 36,107 applied to the same university. Determine the average rate of change in applicants for both schools from 2002 to 2010. So here's the college. The college is 23,142, and it's also then 29,563. So based on that, what's my equation going to look like?
29,563.
Okay.
Minus 23,000.
Good. 29,563 minus 23,142 divided by
2010 minus
2010 minus 2002. Good. So that's how you would set up the first one. This one doesn't have a chart, it's in words. Your next one, what's that one going to look like?
36,000.
Yep. 36,107 minus 689 divided by 2010 minus 2002. So it would just be a matter of performing those calculations. So questions? Okay. Now what we're going to do is we're going to talk about slope, which is exactly what we've been doing. So these first few problems, we've been doing nothing more than finding the slope. They just call it the rate of change because that makes more sense in that problem. But slope is defined as rise over run. And so what we do for the formulas, that's the change in y coordinates divided by the change in x coordinates. And so then here is probably one of the most famous formulas, y2 minus y1 over x2 minus x1. Now, what is the abbreviation for slope? Do we remember? What letter signifies slope? M. Yep. So, actually, M signifies slope. That comes from the French verb monter, which means to climb or to rise. And so in the diagram here, they have a graph and they talk about the rise being y2 minus y1, which is here in your blue. This is your y2 minus y1, your rise. And then this is the run. Okay, so let's go ahead and look at an example. Find the slope of the line that passes through negative 4, 3, and 2, 5. So you can just write those points down. Negative 4, 3, and 2, 5. This is the exact same thing we got done doing with the rate of change, and you seem to catch on to that rate of change pretty well. So we're looking at negative 4, 3 to 2, 5. So to find the slope, I'm going to do the change in y coordinates first. So in this case, I'm going to take 5 minus 3. I'm going to divide that by 2 minus negative 4. So what is 5 minus 3? 2. 2 minus negative 4? 6. So my slope is 1/3. Okay. All right. So we're going to look at another one of those. I'm going to have you try it. Find the slope of the line that passes through negative 8, 11, and 24, negative 9. So quickly, do that right now at your desk. Negative 8, 11, and 24, negative 9.
Are you supposed to get like a pound on that?
Not necessarily. So we should have gotten -9 minus 11 over 24 minus -8. So when you do this, what ends up happening is you end up getting -20 over 32.
You always like minus.
Yes, you always minus. And so now let's go ahead and divide what goes into both 20 and 32. 4. 4 goes into 20. 5 and 8. So your answer should be -5 eighths. What does a negative slope mean?
So you go.
The graph goes down, right. Okay, we've got another example to look at. And then this is going to be finding the slope of the line. Now notice here, instead of actually giving you 2 specific points, it gives you a graph. Okay, this one some of you might think is easier. So what we need to do is pick any 2 points the line goes through. So pick any 2. So I could pick this one. And then where's another point that it goes through? 0, this one? Okay, now this is the nice thing. Instead of saying that this is the point -2, 0, and 0, -3, and finding the slope between them, that's one way. The other way is to just count. Now we're going to make a triangle just like we did in the example. So that's going to be one leg of my triangle. I'm going to count. How many spaces do I have here?
3.
3, but it's a -3 since I went down. Then what I'm going to do is I'm going to go over from this point how far? 2. So my slope is going to be the rise divided by the run. And so the rise here is -3, the run is 2, and that is your answer. So you might like that better. So on those previous problems that we did, you could always plot those points and then just count boxes. Okay, let's find 2 more that they go through. Ooh. Wow. Right before the arrow. Yep, here's one.
8.
The other end, yep, those are the 2. Okay, so the first thing we're going to do is the rise. So the rise is up or down. And so in this case, I'm going to go. So now this is, yeah,
How are those the 2?
because those look like where the arrow goes through. Okay, you're looking for spots that it crosses exactly, like a point here, or a point here, or a point here. You don't want it crossing halfway in between. Okay? You want it to cross exactly, and so if you look at those, it looks like it exactly goes through that point. See, if I went like here, it doesn't go exactly through that point. If I went here, it's close, but still. Okay, so now if you notice here, now this is where you need to be careful. If I look here on the vertical axis, each of those marks is not by 1s. What is each of those marks by? A 2, because see, I've went 0 to 4 here, so that means this is 2. So let's count if everyone's by 2. I've went 2, 6. And is that a +6 or a -6? Positive, because you went.
On the one on the top, could you have gone like up and over?
Yeah, and then you're over with at a negative. So now let's go this way. Biggest thing we need to make sure is how far are the tick marks apart on this one? They're by 2s again. Okay, because I went 0, 2, 4, so let's count. So we've got 2.
4, 6, 8, 10, 12, 14, 16.
So 16. So what is my slope going to be then in this case? 6 over 16, which is 3 over 8. Okay, now believe it or not, this is stuff that's used, they use it a lot like in house building with pictures of roofs. Okay, and so, I mean, slope is something that's very applicable to the real world. And so your assignment here is 79 through 80, 9 through 28. Okay, pages 79 through 80, 9 through 28.